Good evening, everybody. We didn't do too well in hyperbolas while we were in class, so let's talk specifically about graphing hyperbolas, and we will go from there. Here's the watered down version, and let's just go ahead. All right, we'll start from here. This is the slide that we started with. I want to just talk about this kind of parabola first. Looking at these kind of parabolas, if you look at the foci, which is negative c0 and c0, you will see that the foci are on the x-axis. So it tells you that it's going to be a parabola that looks like that. So just to write some things down, this is going to be, say, negative c0 right here. And this right here is going to be c0, being our foci. Now, what we're going to do is, I told you don't worry about this, but let's worry about it because it's going to help you. Remember I said that there can be a box that you're writing inside of your, in between the two hyperbolas. And from here, you will be able to actually, graph using these. This is something you should actually do first. The reason why the box may be helpful is because the length from here to here is going to be A. And the length from here to here is going to be B. And what you'll see is when you actually do the asymptotes, it's going to go through the center from one corner to the other, like this. So it gives you a good idea how to draw the asymptotes, and it gives you a good idea how to actually graph the hyperbola, how far it comes out. So what we're going to call this box right here is we're going to call that box no man's land. That because notice in that box there is no graph and there's no values of x that can be defined under there. So let's call that no man's land. All right. So we're going to concentrate on those kind of parabolas in the problem. Also, the same thing over here. If you have this kind of parabola, the box is, remember, you're going to have a box that looks more so like this. But in this case right here, this is going to be your B, and this is going to be your A. Yeah, that's going to be your A. So I'm going to show you how to use that, or how to do that, and it's the same idea. Your asymptote is going to go in from one corner through the center to another corner on both cases. So it might be helpful, excuse my lines, but just to give you the idea, it might be helpful to draw that no man's land box to help. All right, let's do an example just so I can really get you guys going. Now, it says graph the hyperbola x squared over 25 minus y squared over 16 equals 1. Now remember which parabola we're doing. We're doing this parabola right here. So what always comes first is a squared, and b squared always comes second in this case. Those don't move. The only things that move is the x squared and the y squared. So from here, we can actually say that a is going to be 5 and b is going to be 4. Also, since this 25 is under the x squared, we know that the parabola is going to be this way. And from here, we can tell the x-intercepts. So we'll say the x-intercepts are going to be plus or minus 5. All right? And there will be no y-intercepts. Because if in fact there was an axis right here, notice it doesn't intersect the y-axis at all. So we have that part. So what we do is we have enough to actually start making parts of our graph. Let's start out with the x-intercepts. We'll say here is an x-intercept and here is an x-intercept. So notice also that's the length of A. We'll say that this part right here is A. Now B, remember B equals 4. B is going to be on the opposite axis. That's going to be 4 because B equals 4. So really, let's get an outline for our no man's land to really get that going first. All right. So if I draw this box going all the way around, there's my box. Now this is our no man's land. So really, there's not going to be, there's no, we can't use anything inside of there. Now, also from here, we can actually find our y-intercepts. Well, no, not our y-intercepts because there are no y-intercepts. But we can find out what our asymptotes are. So, with our asymptotes, notice, remember from back here, that our asymptotes in this case, using this kind of equation, is y equals b over ax and y equals negative b over ax. Well, we know what a is and we know what b is. So our asymptotes are going to be positive 4/5 x and y equals negative 4/5 x. So those are our two asymptotes. And what you'll notice is that when you draw those asymptotes as dotted lines, you'll see that they pass right through the corners of the no man's land box and right through the center. So those are the two lines that are drawn. Now from here, all we have to do is we have to solve that for y, solve this equation for y, and get some points. So let's go ahead and solve it for y. What I'm going to do is I'm going to take this equation and simplify it. I'm going to take this y squared over 16 to the other side because it's negative. So that's going to give me x squared over 25 equals 1 plus y squared over 16. Then from there, I'm going to take the 1 to the other side, and that's going to give me x squared over 25 minus 1 equals y squared over 16. Then if I factor out a 1/25th, if I factor this out, what's left inside is x squared minus 25. And that's going to equal y squared over 16. Then if I take this to the other side, if I take the 16 to the other side, that's going to be 16/25 times x squared minus 25 equals y squared. If I take the square root of both sides, then ultimately I end up with plus or minus, I end up with plus or minus 4/5 times the square root of x squared minus 25. And that equals y. So I'll write the y over here. So then from there we can actually make a chart and come up with our values. If we make a chart with our values, we have an x, we have a y. Now remember here, since this is no man's land, you cannot use any of the x values inside of our box. So you can only use values that are on the edge of the box and outside. The first value you can probably use is, of course, 5. Now if you plug a 5 into this right here, I will show you. You punch 5 into this function right here, well, this equation, you're going to get, well, I don't want to show that yet. you're going to get 0. If you punch 6 into, if you put it into this equation, what you're solving now is basically 4/5 times the square root of 24. And you'll notice that you're going to, once you punch that in your calculator, it should come up 2.6. And when you punch 7 in your calculator, you should get 3.9. And for 8, you should get 4.99 when you punch those. So really what you're doing is you're just graphing those points. Say, for example, 50 is already plotted. If you want to plot at 6, 2.6, 2.6 is probably like right here. Plot 7, 3.9, that's right around here. And at 8, you want to plot 4.99, it's even closer here. So what all you have to do now is, since this is a symmetrical curve, you just have to mirror it into the other parts. So since this is at 2.6, bring it down to negative 2.6. Since this is down to 3.9, bring it down to negative 3.9. And since that's 4.99, bring that down to 4.99. Same thing over here. Just mirror those over to this point. Let's see, 6. At 6, it's at 2.6. Well, so negative 6 is at 2.6. At negative 7 is going to be at 3.9. And negative 8 is going to be at 4.99. And then pretty much the same exact thing down here. So negative 2.6. That net 7 is going to be 3.9. And here's going to be 4.99. So once you have all of those points, you can draw your curve to try and match those points. It's not going to look as good as this one is. Mine points don't even look as good as, but it should follow the points that you have. So once you have that, you've drawn your hyperbola. I know this is a lot and it takes a lot of time, but as soon as you're done, it's a lot of work, but now hopefully this video helps to help you guys get it done. So please email me with any questions, and good night.